So I'm going to talk about epidemiology, randomized trials, and the search for what works in economic development. Epidemiological methods, including randomized controlled trials, have recently become very popular in economics. There was a previous wave in the 1960s and 1970s of, in some cases, very large-scale trials, which died and have sort of vanished out of the literature. One of those is somewhat exceptional, the Rand Health Insurance Experiment, whose results still get quoted and are still used and are active in the literature. The movement of epidemiology into economics I want to characterize by a switch towards a target of empirical analysis is seen as the estimation of an average treatment effect. So that we've got these individual treatment effects which are heterogeneous and usually unobservable, and it implies this focus on average treatment effects, as in epidemiology, that other estimations are assessed essentially by how closely they approximate a randomized controlled trial. I think traditionally in economics, the average treatment effect was not the standard that we were looking for. And I will come to that in the end, but I think in the past we would seen our task as understanding heterogeneity and reducing heterogeneity rather than simply trying to estimate an average. Let me talk a little bit about economic development. The background here is what was seen at the time as the failure of development economics and indeed of the whole development project. The World Bank, when challenged by the first of the two George W. Bush administrations to document whether it had ever done any good in the world, had an incredibly hard time coming up with anything. And it's worth looking at those documents. They're the most singularly unimpressive bunch of piffle that you've ever read. They're just sort of making up stuff and claiming stuff, which was really terrible. And there's a very deep skepticism, not just in academia, but also in policymakers among the bank's own about the bank's own internal evaluations. In the broader context, many argued that there had been little or no progress in poverty reduction. I mean, poverty reduction there has certainly been in the world, but whether the development enterprise had anything to do with it is very much in doubt. And this was sort of linked to not knowing what we were doing. And many people made that link back to the evaluative failure and this sort of feeling that if we'd done the evaluations better, then by 2000, say, we'd have known what we were doing, and poverty would have been history. At the same time, there was a lot of dissatisfaction with the econometric methods for evaluation, with technical fixes, with the various adjustments that were made all the time. And RCTs sort of seem to promise a solution, if indeed that is the problem. So RCTs were seen as a tool of global poverty reduction around the world by sort of finding out what works. Let me do some general things as to what went on in economics and build some of the links with Snow. There was a very important paper by David Friedman, one of my great heroes, called Statistical Models and Shoe Leather, which I don't think caused the spate of natural experiments in economics, but certainly had a very large effect in reinforcing it. There were a bunch of natural experiments around that time in economics, many of them originally from Princeton. Some of the people in Princeton had been involved in the earlier wave of experiments and never quite given up on them. And there were some very clever natural experiments at that time. And I think when they first came out, most of us thought these were flukes in that, you know, you weren't going to get these natural experiments all the time, but a bunch of people managed to show that you could generate a lot of natural experiments and use it as a methodology. So let me tell you something about some of those. One of them is about labor economics and going to war. The Vietnam lottery, the Vietnam draft randomized draws for drafting into the military. So think of this, you either get a bad draw or you get a good draw. And if you get a bad draw, you're supposed to go to Vietnam, and if you get a good draw, you didn't. The intellectual puzzle was that people who went to Vietnam, the Vietnam vets, typically had lower wages after the war than those who did not go to Vietnam. And that contrasted with what had happened in World War II, whereas those who'd gone to war had higher wages than those who had not gone to war. The standard theory is that what you learn in the military about killing people and so on is not very useful in civilian life, and so basically it's just a complete waste of time, and so you should lose wages for otherwise experience. And it did turn out, indeed, that those with worse lottery numbers had lower wages. The lottery numbers were clearly randomly allocated, and so the implication was the Vietnam one was the right answer, and the World War II was essentially from adverse selection, that if you didn't go to World War II, it was because you had something wrong with you. Another famous study involved fast food joints between New Jersey and Pennsylvania. New Jersey increased its minimum wage. Pennsylvania did not. And there was an increase in employment of fast food workers in New Jersey relative to Pennsylvania, the opposite of what standard theory would predict. This provided some pretty vituperous stuff. From the right in particular, Nobel laureate James Buchanan accused the authors of being camp-following whores, and that if you accepted this result, it deprived economics of any scientific content. Thomas Sowell referred to it as cold fusion, and June O'Neill, who was running the budget office for the federal government at that point, also pointed out that theory is also evidence. See what you make of that statement. Here's New Jersey, where I live. Here's Pennsylvania. One of the things I want you to note for later is that Pennsylvania is a rather large place relative to New Jersey, which is actually a much smaller state. Final example, schooling and earnings. Most countries have rules about how old kids have to be to start school. That induces arbitrary discontinuities in the years of education. So imagine a child who's going to leave school just as soon as they can, say at 15 or whatever, and is born on December 31st, compared with someone born a few minutes later on January the 1st. Then the one who's born on January the 1st goes to school a year later, and so you get this discontinuity in the amount of education. So you can actually look and see whether the people who are born at the end of December have higher wages than the people who were born at the beginning of January, and the answer is yes. Schooling is causal for earnings, and the size of the effect is actually very close to what had been estimated in 50 years of observational research. Now, the next part of the story is that these stories began to come apart. And the credibility of some of these studies, at least, is worn thinner over time. Now, one of the things, and we can learn something about trials in economics, at least from doing this. So the young man who had bad lottery numbers knew they had bad lottery numbers and could do something to avoid the draft. Similarly, the ones that got good lottery numbers and still went were people who thought they weren't giving up very much by going. And so you got a selection after the randomization by the individuals depending on how good their labor market prospects were in the US, which completely screws up the estimation of the thing. And the problem here from an epidemiological point of view is the failure of blinding, in that these people knew what their allocation was and had time to do something about it before the treatment was applied. So it's sort of like, you know, agricultural plots can't sort of say, oh my God, that fertilizer looks bad, let's get the hell out of here. Whereas people who get a bad draw for the military can actually do something about it. It turned out the minimum wage result in Pennsylvania came from a fall in employment in Pennsylvania where nothing had happened, rather than from an increase in employment in New Jersey, which makes you think maybe something else was going on. It also turns out the rhetoric of this study was that all of these places were McDonald's just along the border, but in fact some of them were hundreds of miles apart. So one would be on the seaside in New Jersey, and the other would be in the mountains of Pennsylvania in the far distance. It also turns out from a bunch of other studies that people born at different times of the year are different in lots of other ways. It turns out that different socioeconomic status groups have very different seasonal fertility patterns, and so the mix of parents in December is different from the mix of parents in January. And this confounds a tremendous amount of what you're seeing from these apparently rather clever studies. People born in April have lower life expectancy at 50 than people born in October. Or that used to be true. It's now wearing off over time. So our response, one response in economics, We call this a failure of exclusion restrictions. The exclusion restrictions, the way we think about it, is the natural experiment works not only through the mechanism of interest, but through other uncontrolled channels. That's what we call a failure of exclusion restrictions. The exclusion restrictions being that the natural experiment works only in the way that you want it to work. It doesn't have any effect anywhere else. In the snow, that would be if the allocation of households to water companies disguised income, occupation, or class differences, which Snow was very concerned about and tried his best. This mixing business we heard about yesterday, and economists tried to do that too, but you can't buy protection against unobservables that are later made observable by further researchers who come along and say there's something you left out, and look, this is really important. So one response, at least, was to do real experiments, to do randomized controlled trials. There's a rejoicing headline in The Lancet saying the World Bank is finally embracing science. Notice this very strong political use of the word science, with each side trying to capture it for themselves. And then there's this nice quote of Esther Duflo's about how randomized evaluations are going to change economics and social policy in the way that they revolutionized medicine. I'm not sure where she got her history of medicine from, but nevertheless. So what are we learning? I mean, there's now been enough of these studies to see some general issues, both statistical and philosophical. Like studies before them, and like observational studies, some of these are terrific, and some of them are truly terrible. And I just want to say up front, I'm somewhat of an RCT skeptic, but nevertheless, it's clear that an RCT is sometimes exactly the right thing to do, and identifies just what we want to know in situations that sometimes it would be very, very hard to get that information in any other way. But there are many issues, some of which are specific to economics, and some of which I think are more general. So I'm going to talk about some of the economic-specific ones first, and then come into some more general issues. I don't want to leave the message. I did grand rounds at NIH and talked about this, and I was expecting to be eaten alive before I got out of the building. And people were really nice to me, and fed me and gave me nice wine and things when I went away. And I thought, well, what did I do? Why didn't they get angry? So I called up my friend who'd set the thing up, and he said he checked, and when he came back to me, he said, well, they really liked what you said. And I said, oh, yeah? And he said, yeah, you said that economists don't know how to do randomized control trials. Actually, after listening to Richard Pito this morning, there's something to be said for that, actually. And whenever I want to convince myself, when I'm getting too skeptical, I go back and read Richard, so I owe you in the debt for that. All right, so one of the issues that I think is peculiar to economics, or much more important, is what economists call general equilibrium considerations or scaling up considerations. Now, in many experiments, what happens to scale must be different from what happens in the experiment. One example is if you educate kids in poor countries and it gets them better jobs, and a better job is defined as a job with the government. If you scale that up and the government doesn't expand any more jobs, then it's not going to have the same effect it has in the experiment. Another example I was involved with in the World Bank is innovations in cocoa horticulture. And once again, they had all these good innovations for increasing farmer productivity. It brought the world price down and bankrupted all the farmers. Another example that's going on in India now, and is a very bitter debate, India has a system of in-kind food subsidies which are very efficient and very inefficient and very corrupt. And there's a lot of discussion about replacing them with cash. And you can do localized experiments and find out whether people like this better than they like getting the food. But you can't do the two things that people are really worried about, which is what will happen to the price of grains if you did this over the whole country. And if price index goes up in general, the price of food goes up, will the government up the cash transfer, or will it say there's a financial emergency, sorry guys? And now they get the food, and the money and the food are not the same thing. I talked to Paul when I was preparing this. He pointed out there are herd effects of vaccination, but it otherwise is relatively rare in medicine. There's not much in the way of spillovers from what happens to one individual to what happens to the population as a whole. But I think this is actually central in what economics does. The other thing I want to talk about a little bit is we're often told that RCTs solve the selection and bias problems. And it's become clear in economic development that's just not true. And that's because, and again, Richard referred to this morning, and maybe he's learned to live with it. I'm not sure I've learned to live with it. These guys are doing small-scale experiments on convenience samples. So if you do the experiment perfectly, and it all comes out, you've estimated the average treatment effect for a convenience sample. If you did an observational study on the same convenience sample, no one would publish it because it's a convenience sample. Yet somehow, if you estimate this using randomized controlled trial, even though you're targeting the same parameter, suddenly that's okay. And I don't know why that really is. And it's become a huge problem in development and many health delivery experiments in development. And there's this sort of idea that if there's randomized somewhere, then that's a rigorous number. It's the sort of magic of RCTs. I think this is familiar in medicine. For instance, the exclusion of people with comorbidities from drug trials, when that rules out most of the elderly people, and most of the elderly people consume most of the drugs, which is a somewhat odd procedure. The other thing that I've learned in doing this, and if this is widely known, I didn't know it, which is that even if you do this randomly, so let's say you don't use a convenience sample, so if you select 100 villages from all the villages in the country, you then split them into randomless, two groups of 50, then that first stage randomness can be deeply problematic. And this is essentially a small sample problem, but it's a much bigger small sample problem than was apparent to me. And this is to do with outliers, and it's to do with when treatment effects are widely asymmetrically distributed. A microfinance would be an example. You give a lot of women small sums of money. One of them is a budding entrepreneur who's going to get very rich. The other's not going to do anything. Where that person is in your control or experimental group determines everything, and you basically got one sample point, not 100 sample points. And then it turns out the t-values don't work in that situation, and there's really terrible and surprising problems. The underlying theory under this is the Bahadur-Savage theorem from 1955, which, this is sort of an amazing theorem, given how we do this all the time. But it says that the t-statistic for the difference of two means has 0 power, unless we put further restrictions on the underlying distribution of treatment effects. So this is a problem about third moments, and it's a problem when you've got asymmetry in the treatment effect. You get many weird counterintuitive results, spuriously significant. It looks like you have a big sample size, your t-value looks great, and it's not. You've basically got nothing there. Now, often in medicine, these treatment effects can be transformed. In economics, they often can't, because we want to know about money outcomes. And if you're going to do the cost effectiveness or cost benefit analysis, you've got to do it in money, not in the logarithm of money, for instance, which would get rid of this problem. So I don't know how to solve that either. I promised Paul I'd talk about this, and I'm sorry I'm running out of time, but there's this old debate, which I don't believe has been resolved, and it's come up again in economic development between Fisher and Gossett. Gossett, of course, was a student, invented the student t-statistic about agricultural trials. Gossett had a long war with Fisher, which, in my reading of the literature, Gossett won and Fisher lost, but it's remembered exactly the opposite way around. And there's a paper in Biometrica in 1938, which was Gossett's last paper. It was finished for him by none other than Neyman and Pearson. And the problem is this, that once you've done the randomization, but before you've spent any money, so you randomized on the field plots, you look at this and you can tell the experiment's going to fail, depending on the randomization, because it turns out that all one kind of plots are in one end of the field and all the other sort of plots are in the other side of the field. Now, the economists who are doing these randomized controlled trial in development apparently are finding this happens all the time. You know, they've got a limited budget, they've done a field experiment, they look at these outcomes, and they say, I'm not going to do that. I'm not going to waste my money doing that. So then what do? They re-randomize. Right? They won't admit this, or they'll admit it in private if you lock them up somewhere, but you can't find it in the papers. And they randomize and re-randomize and re-randomize and re-randomize until eventually the randomization passes some sort of balance check table. Now, they're very ashamed of that. And if you ask them to do that, they say, no, I never did that. That would mess up my experiment. But my argument is that's way better. And that's actually what Gossett argued too. Now, stratification can do some of this. But if you've got hundreds of variables with hundreds of values that you want to balance on, stratification is no good at all. Whereas this repeated randomization can solve that problem, and you're going to reduce the variance of the estimator, and that's what Gossett argued. Let me skip the other slides, or worse. I just wanted to say something about what we're learning from experiments, which is how do we know that the results of the experiment, the average treatment effect, will apply either to individual units who might even have been in the RCT or beyond the control of the experiment. Now, to me, the key to this is understanding the mechanisms. What we heard yesterday, processes, the mode of transmission. That's, I think, what we must really understand. Causality, which is certainly established by an RCT, is often thought to help generalizability. And you're now seeing in economics the word causal appearing in the titles of papers all of the time. And it's not clear what epistemological status that word has. And two problems with causality. One is that it's often local. It's constructed of small links. And those links are hooked up differently in different places. My friend Nancy Cartwright, who I've been working with on this, likes to use the analogy of a lever, or a lever, as it's called here. And a lever works differently on a toaster from the way it works on a toilet. And, you know, if you've been toasting bread happily by pushing this lever, and, you know, it doesn't transfer. And that's because the causality works differently in different places. Put in economics term, the incentives to reform will work differently depending on the social and economic structure. The second point about causality, it's often what the philosopher Mackey has called the Angus causality. Angus stands for an insufficient but non-redundant part of a condition which is unnecessary but sufficient. Now, when you say something like that, you realize why most of us would never make it as philosophers. The classic example is that the house burned down because someone left the television on. Right? Houses don't usually burn down when you leave televisions on, but that's a perfectly causal statement. It was, but it didn't work without helping factors, without the wiring being screwed up or someone left something around. But knowing it's causal is a very limited value for understanding how it's going to work in other places at all. So I don't think causality is nice. I've got nothing against it, but in itself it's not very helpful. So here's my final slide. Where should we go? To me, understanding mechanisms is the key to progressive science in economics and elsewhere. RCT can often be dispositive about a hypothesis, but then so can many other kinds of experiments or pieces of empirical evidence. Now, to me, Snow's great work was great because he had a specific hypothesis in mind. He knew, or thought he knew, what caused cholera. And he had an acid test, what David Friedman calls an acid test, which is the water companies or the maps and so on, for understanding, for decisively convincing people that his theory was correct and other theories were almost certainly false. And it was not because it was like an RCT. So its greatness is not that it led to RCTs. To me, its greatness is that it had a very clear hypothesis and a very clear, decisive, and clever way of testing that hypothesis. This is what Popper called the hypothetico-deductive method that can apply to RCTs, but most RCTs that are designed to find out what works are not hypothetico-deductive science at all. And to me, in economics, we need a closer contact between theory and testing. We need to find out not what works, but why things work. Thank you. Done.